Good morning and welcome to Integrated Math 1. I'm your host, Doc Turner. Today we're going to be talking about 6.2, which is looking at relative frequency tables. This is going to build on 6.1, which is looking at two-way frequency tables, so if you're not familiar with that, you may want to go back and look at that video first. But 6.2 relative frequency tables, as the name might imply, is looking at relative frequency. So relative to the total number of people being surveyed, what portion or what percent or what part of that group falls into each of these categories is the idea. This is important because when we look at frequency, this is going to vary based on a lot of different factors when you're taking a survey. It could change based on the sample size. It could change based on how you're collecting your data. So relative frequency is important. The goal here in 6.2 is to be able to first construct a relative frequency table and then to be able to answer some questions based on that. So let's go ahead and get started here. Okay. I already went ahead and just typed in these, so you guys aren't watching me have to do all this, and just threw in some random examples here. So in the first example, we have a group of people at a park, 200 total. Options at the concession stand were either pizza or hot dog, and then soda or water. And then the totals are written down. Example 2. Between middle and high school students who had a uniform or did not have a uniform, and the totals, with a total of 500 people surveyed. And then example 3, preference on a shirt, short or long sleeve, blue, red, or green, a total of 60 people surveyed. So we'll go ahead and jump right into it here. So when you are constructing a relative frequency table, as I mentioned, it is relative to the total number of people surveyed. So to construct the relative frequency table, what you're going to do is you're going to use a calculator or do it by hand, and you are going to calculate the percentage or the decimal of each of these boxes. So for instance, there were 120 people that ordered soda and pizza out of a total of 200. So to find the relative frequency of that, I would do 120 divided by 200, which gives me a value of 0.6. Now usually you're not going to end up with a clean decimal like that, and so the directions will specify round to the nearest tenths place or hundredths place, etc. And then you're just going through and doing that for each of these. Again, using the calculator, so 30 divided by 200, 150 divided by 200, 40 divided by 200, 10 divided by 200, 50 divided by 200, 160 divided by 200, 40 divided by 200, and 200 divided by 200. Now, typically in a relative frequency table, you're going to list these as decimals, but you could easily convert these to percents by moving the decimal place 2 places to the right. So, for instance, for people who ordered pizza and soda, that represents 60% because the decimal is 0.6. People who ordered water and a hot dog, 0.05, that represents 5%, etc. But for the table itself, we typically leave it as a decimal. Now, a couple things we want to be aware of. One is that just like with a regular frequency table, a relative frequency table, your columns and rows should still sum. So 0.6 plus 0.15 adds up to 0.75. 0.15 plus 0.05 adds up to 0.2 or 0.20, etc. So that all should still be true. If not, it means that you may have made an error, or if you had to round, you may have made a rounding error. So double check your work. And the total at the bottom should always be 1, which represents 100%. So half of your assignment is going to be constructing a relative frequency table, and then the other half is going to be answering questions based on that relative frequency table. So like we just did, if I asked you what percent of people, ordered a soda and pizza, you would tell me 60%. What percent of people total ordered a hot dog? 25%, etc., etc., etc. Okay. So let's try this middle example here. So I have a total of 175 who ordered a uniform in middle school out of 500. So I can use my calculator to get 0.35. And you don't have to keep it up obviously, but 25 divided by 500, 0.05. Now for this example, I try to choose decimals that we're going to divide nice and evenly. So again, you can do this with a calculator, but once you divide each of those numbers, you end up with the following. Okay. So then based on that, I could ask you, what percent of people were in middle school with no uniform? So you would look at the table, 0.05, so that represents 5%. What percent total had no uniform? Looking at the table, 0.15, 15%. Total number in high school, 60%, etc., etc., etc. Now, because we're doing this online, I'm trying to give you guys fairly simple examples. Here, for the most part, we've been comparing two things, or two choices to two choices. However, we can do that for more. It could be a 2 by 3, it could be a 3 by 3, it could be a 10 by 10. So for instance, in example 3, I have 3 options for color, blue, red, and green, and 2 choices for length of the shirt, short and long. So that creates a total of 6 boxes inside, and then of course we have my totals going along the last row and column. Now here, I specifically put a total of 60 to show that it won't always divide evenly. So for instance, 13 divided by 60 gives me a repeating decimal. As I mentioned, usually your directions are going to specify round to the nearest tenths place, or round to the nearest hundredths place. So for now, let's say we round to the nearest hundredths place. So that would give me a decimal of 0.217 here. Okay. And then 19 divided by 60 gives me 0.317. 15 divided by 60 would give me 0.25. 47 divided by 60 gives me 0.783. And then going along the long sleeve, 7 divided by 60, 0.117. 4 divided by 60, 0.067. 2 divided by 60, 0.033. 13 divided by 60, 0.217. Of course, my total should be 1, 60 divided by 60. Here, 0.333. 23 divided by 60, 0.383. And 17 divided by 60, 0.283. Okay. Now, a couple things here. Okay. First of all, this still applies, just like it did in the other examples. We said that each row and column has to sum. However, if I were to just say take these 3 and add them, I'm going to end up with 0.999. If you are having to round to the nearest hundredths place, then it is possible that your percentages are going to be a little bit off, and maybe it doesn't add up each row and column, and that's because of the rounding. So just be aware of that, there is a potential to be off by a little bit, and that's okay if you had to round. So this adds up to 0.999 because I rounded down each of those repeating 3 decimals, so that's okay. Regardless, you could still be asked to fill out the table and still ask some questions on it. For instance, people that preferred green short sleeves, that was 25%. People that preferred red long sleeves, that is 6.7%. People that preferred blue short sleeves, 21.7%. People that preferred long sleeves total, 21.7% as well. So remember, when you're converting the decimal to the percent, you just have to move that decimal place 2 places to the right, And that's it. That's it for today, guys. If you have any questions, please reach out during office hours. Otherwise, have a good day, and I will talk to you soon. Bye.